Hello Mzansi, welcome back to another episode of Farmers Inside Track. I'm your host Duncan Masiwa and I'm back for this episode powered by Pannar Seed. Now we're joined by Kerry Rowlands, a seasoned agronomist and field agronomist for Pannar Seed. Now with over 2 decades of experience, Kerry shares her expertise on the critical factors that influence successful seed germination, a fundamental step toward a high-yielding harvest. In this episode, we'll talk about the essential biological steps of seed germination, practical tips for maize farmers to ensure good germination, and of course, so much more. Kerry, welcome back to another episode.
Thank you, Duncan. It's good to be here.
Fantastic. I'll jump straight into it. Why is it important to understand seed germination and the conditions that support it?
At its core, a maize seed is a dormant plant embryo. Its only job is to germinate. Once that happens, everything else depends on external factors like soil, moisture, fertility, weather. Germination is the launch pad for the entire growing season. If it goes well, you're off to a strong start with potential for high yields. But if germination is poor, you're already behind before the plant even emerges. It's kind of like tripping at the start line of a 100-meter race. Understanding germination helps farmers make informed decisions about planting conditions, timing, and inputs. It also gives insight into the biology of maize, which can be incredibly useful when you're troubleshooting issues in the field. When you know what's happening inside the seed, you're better equipped to create the right environment for it to thrive.
It all starts with the seed and, of course, the right seed, I suppose, Kerry.
Absolutely.
Walk us through the basic biological steps of seed germination.
So germination begins with water absorption called imbibition, which rehydrates the embryo and activates a hormone called gibberellic acid. This hormone is key because it converts stored starch into sugars, which gives the embryo the energy that it needs to grow. The next step, the seed coat softens and swells, which allows the embryo to break free. The radicle, which becomes the primary root, pushes downwards into the soil. At this stage, the embryo also starts absorbing phosphate and zinc. Phosphate helps with the energy transfer and DNA production, while zinc supports starch conversion and auxin production, which drives cell division and elongation. Cytokinins are also produced. These hormones trigger cell division and differentiation, which are essential for root and shoot development. So as the radicle anchors the seedling, the plumule pushes upwards to form the shoot system. The cotyledon emerges to nourish the seedling for those first few days until it can photosynthesize, and eventually true leaves develop and the plant transitions to independent growth. From there, it matures into a maize plant with tassels and ears, ready to produce the next generation of seeds. It's a beautifully orchestrated process and every step matters.
Listen, you described it so beautifully. I could almost see the entire process unfolding. So it's beautiful. What should farmers do to ensure good germination of their maize seed?
I like to think of it as following the terms and conditions for germination. There are 3 key ones. 1 is planting depth, 2 is soil moisture, and 3 is nutrient support. Each of these plays a vital role in helping the seed transition from dormancy to active growth. If any one of them is off, it can compromise the entire process.
I like that. Let's maybe stick there for a second, starting with plant depth. What should farmers keep in mind?
Planting depth directly affects soil temperature, which is crucial for germination. Shallow planting exposes the seeds to greater temperature swings, up to 10 to 15 degrees Celsius daily, because that layer is influenced by air temperature, sunlight, and wind. And those fluctuations can lead to chilling injury, especially if cold enters the seed early in the morning. Deeper planting offers more stable temperatures, typically fluctuating less than about 5 degrees Celsius. This stability supports consistent moisture absorption and uniform germination. It's also worth noting that planting too deep can delay emergence, while planting too shallow can expose the seed to drying out or damage. So finding that sweet spot is key.
This is quite helpful, Kerry. Let's talk about soil temperature. How should farmers measure soil temperature and what are the ideal conditions?
To get an accurate picture, you need to measure the soil temperature over 7 days and also check the forecast for the next 48 hours after your planned planting day. On your planting day, test the soil just after dawn. That's the coldest time of day. And this gives you the true ground temperature. It's also important to note here that the ground temperature that you're measuring needs to be at soil planting depth. Ideally, the soil temperature at planting depth should be above 10 degrees Celsius. But for optimal germination, you want to aim for over 16 degrees Celsius for 5 consecutive days. Cold soil can delay germination and also cause imbibitional chilling injury. So here's the golden rule. Always measure at planting depth, not just at the surface. That is where your seeds are going to live and grow.
Imbibitional. It's the first time ever hearing that word. What is imbibitional chilling injury and how can it be avoided?
Imbibitional chilling injury happens when seeds absorb cold water during the first 24 to 26 hours after planting. During imbibition, the seed swells and its cells stretch. But if the water is too cold, the seed's elasticity is reduced and the cells can burst. The most common symptom is a swollen seed with little or no signs of germination. If you see a corkscrew-shaped mesocotyle, it means that germination occurred, but cold injury affected the shoot tissue afterwards. This can stunt the growth and significantly reduce yield potential. To avoid this, plant when the soil temperatures are consistently warm and stable. It's a small detail that makes a big difference.
You mentioned moisture as another key condition. What should farmers know about this?
Moisture balance is absolutely essential. Too much water in the soil means there's no oxygen and the seedlings can actually suffocate. Too little water leads to poor seed to soil contact. So seeds swell, but then don't germinate. When planting in overly wet conditions, you might see brown necrotic tissue on roots and shoots or leaf shoots bursting from the side. These are signs of stress and poor development. The goal is to plant in soil that's moist, but not saturated. Think of it like a wrung-out sponge. That's the kind of environment where seeds can absorb water, breathe, and grow.
What about nutrients, Kerry? Should farmers use fertilizers? And if so, what kind?
Yes, especially when conditions are stressful. Starter fertilizers with phosphate and zinc are ideal. Use a pure phosphate suitable for in-furrow use to avoid fertilizer burn. Smaller, finer particles help to improve uptake. And then for zinc, go with fully chelated forms. They're more available to plants, especially in high pH soils. Zinc acts like oil in an engine. It helps everything to run smoothly. It boosts plant height, leaf length, and leaf area, all of which contribute to stronger, more resilient seedlings. And remember, early nutrition sets the tone for the rest of the season. It's an investment in your crop's future.
An investment in your crop's future. What are biostimulants, Kerry, and plant growth regulators, and how do they help?
Yeah, biostimulants are being used more and more these days. They are naturally derived substances like humic acid, fulvic acid, and kelp that can enhance plant growth. They improve soil structure, increase nutrient uptake, and also help plants cope with stress. Plant growth regulators are hormones like auxins, cytokinins, and gibberellins that control plant development. They regulate cell division, elongation, and differentiation. Together, these substances boost plant vigor, they speed up emergence, and improve establishment. They also increase resistance to environmental stresses and improve nutrient availability. Think of them as performance enhancers, not in the synthetic sense, but in a way that supports the plant's natural processes.
Kerry, you've given us great insights into successful seed germination, which is considered a fundamental step towards high-yielding harvest. We've talked about the essential biological steps of seed germination, how to avoid imbibitional chilling injury, nutrients, biostimulants. What is your final message for farmers that are aiming for high yields?
Germination is the most critical phase of crop production. It's where everything begins. So get it right. Plant at the right depth. Monitor the soil temperature carefully. Ensure good seed to soil contact. And then, if you can, support early growth with nutrients and biostimulants. These steps may seem very simple, but they're powerful. They lead to robust plants, uniform stands, and ultimately better harvests. If you can get germination right, you've already won half the battle.
There you have it, Kerry Rowlands, field agronomist at Pannar Seed. You can, of course, read more on this topic by visiting www.foodformzansi.co.za. Remember to subscribe to our podcast on your favorite platform so you never miss any of the episodes. From me, Duncan Masiwa, our technical producer, Megan van der Vent, and the rest of #Team Food from Zanzi, thanks for listening.